Now I'm going to work 4b for you from the exam review. The instructions say solve the absolute value inequality. Again, another inequality that has an absolute value in it. An absolute value always requires two cases. An inequality sign that is a less than means it's an and problem. We worked for A, it was an or problem. So my regions did not need to overlap. Now it's an and problem, so we're going to have to deal with that issue. Now, again, I'm going to have the case where it was positive and the case where it was negative, so I can write x minus 4 over 3 is less than 8, and x minus 4 over 3. And again, I'm taking my negative case now, so I'm moving it from over here to this side, so I change the direction of my inequality, and x minus 4 over 3 is greater than negative 8. Now this can be worked as one compound inequality. If I put them in order least to greatest, I can write this negative 8 is less than x minus 4 over 3, which is less than positive 8. I have the same two inequalities. I just put it in one, and this way I can solve it as one compound inequality. You can also solve it this way. Either way is fine. I'll solve on this way. First thing I want to do is get rid of that denominator, because remember, I'm trying to isolate the x in the middle of my two inequalities. So I'm going to multiply through by 3, and that gives me negative 24 is less than x minus 4, which is less than positive 24. Now I'm going to add 4 to all three sides. We did that on a previous problem where we had a compound inequality. The minus and plus 4 here cancel. Negative 24 plus 4 is negative 20 is less than x, which is less than 24 plus 4 is 28. Okay, this one more clearly tells you that x has to fall between negative 20 and positive 28. Here I would have ended up with x is less than 28, and I would have ended up with x is greater than negative 20. That one's a little harder to see when you've written it that way, that it actually falls between those two numbers, which you can, however, see when you go to graph it. It's just as clear for both. Those are my two critical points. I have negative 20. I have positive 28. X is less than 28, not including, so I put an arrow like this. X is greater than negative 20. My arrow goes like this, and it's everything that falls in between. If you begin by graphing the two on the top, I would have said x is less than 28 goes that way, x is greater than negative 20 goes that way, and remember the rule is on an and that the graph has to overlap. The only solutions are where it fits this graph and it fits this graph, which would only happen, of course, between here and here. Well, I've moved it over a little bit, but the area that overlaps it. So it's a little easier to see this way, and that's why I prefer to solve my compound inequality in that method. And here I have my inequality notation. If I wanted to answer this in interval notation, I would be going from negative 20 to a positive 28. Neither endpoint is included, so I have parentheses. If I wanted to write this in set notation, it's going to be x such that negative 20 is less than x is less than positive 28. Again, set notation using inequality notation, interval notation, and my final graph. And there you go.